Phase diagram of water. But before that, what is phase diagram? Phase diagram is a graphical representation which shows what phase a substance will be at a particular temperature and pressure. We can see that the pressure is placed on the y-axis. On the other hand, temperature is on the x-axis. This part is when the substance is at the solid phase. This part is when the substance is at the liquid phase. And lastly, this part is when the substance is at the gaseous phase. On a phase diagram, there's also this. Phase boundary is the line that indicates the condition under which two states of equilibrium of matter exist. Based on the figure, the point along the line connecting point A and B in the phase diagram represents all the combinations of temperature and pressure at which the solid is in equilibrium with the gas. At this temperature and pressure, the rate at which the solid sublimes to form a gas is equal to the rate to which the gas condenses to form a solid. The line between point B and C contains all the combinations of temperature and pressure at which the liquid and gas is at equilibrium. At every point along this line, the liquid boils to form a gas and gas condenses to form a liquid at the same rate. The line between point B and D contains all the combinations of temperature and pressure at which solid and liquid is at equilibrium. At every point along this line, the solid melts at the same rate at which the liquid freezes. Triple point. A point in which the unique temperature and pressure at which the solid, liquid, and gas phase of a substance are all in equilibrium with each other. Point B in this phase diagram represents the only combination of temperature and pressure at which a pure substance can exist simultaneously, a solid, a liquid, and a gas. Critical point is when the condition of temperature and pressure at which densities of a liquid phase, gaseous phase, becomes equal. You can no longer distinguish the matter if it's liquid or gas. The temperature and pressure corresponding to these are known critical temperature and critical pressure. We can see the phases we would expect at a particular atmospheric pressure and temperature. Pressure is proportional to temperature. It means that when the pressure increases, the temperature increases. When the pressure decreases, the temperature decreases. For water, the lines between the solid and liquid slants up and left because the solid form is less dense than the liquid form. In this case, as the pressure goes higher, the temperature decreases. The reason is that if you have this equilibrium and increased pressure in it, according to Le Chatelier's principle, the equilibrium will move to reduce the pressure again. That means it will move the side with smaller volume liquid is produced. To make a liquid water freeze again at this higher temperature, higher pressure means lower melting or freezing point. If the pressure increases up to 0.006 atmospheric pressure, water would sublimate as the temperature increases, instead of melting first. If the pressure goes higher than 0.006 atmospheric pressure, we can witness how it is possible for a substance to undergo through all phases of matter as the temperature increases. When the pressure is at 1 atmospheric pressure, the point that crosses the solid-liquid equilibrium and liquid-gas equilibrium would be the melting and